The Pythagorean identity is an important identity in trigonometry. It should not be confused with the Pythagorean theorem. The Pythagorean theorem is about right triangles, and the Pythagorean identity is about the sine and cosine functions. Now they are related, but they are not the same thing. So if you're asked to state the Pythagorean identity, you should not be talking about the Pythagorean theorem. You should be talking about the Pythagorean identity, which is the sine and cosine functions. So what is the Pythagorean identity? We'll write it down first. Sine squared theta plus cosine squared theta is equal to 1. Now when we write sine squared theta like this, we actually mean sine of theta quantity squared. Putting the square there is a mathematical convenience. It's actually easier to read when things get more complicated. So just get used to that idea right now. Sine theta squared is the same as, I should say, sine of theta squared is the same as sine squared theta. Okay, so this is the identity. The question is, well, what does it say? Where does it come from? Well, let's just make the substitutions and play around with the algebra. So we know that sine of theta is y over r, and cosine theta is x over r. Now if we square the fractions, we get y squared over r squared plus x squared over r squared is equal to 1. Clear the denominator, we get y squared plus x squared is equal to r squared. But more typically, we write the x first, so x squared plus y squared is equal to r squared. So what is this thing saying? This is actually the formula for the circle centered at the origin of radius r. This was the circle that defined our functions, right? We had a point x, y, had a radius r, and an angle theta. And so what this statement is actually saying, it's just a reflection of the fact that our sine and cosine functions are built out of a circle. And so the Pythagorean identity is a way of stating that using just the sine and cosine functions. One of the interesting things we can do with the Pythagorean identity is that if we know the value of sine or cosine, we can find the value of the other function as long as we have one more piece of information. So let's take a look at this example. Suppose that sine of theta is equal to -1/2 and theta is in the fourth quadrant. Determine cosine of theta. Well, let's think about this for a moment. First of all, in our xy plane, we know that our angle is somewhere in the fourth quadrant. Now, it doesn't matter which way we label it. We could label it, think about theta going this way in the positive direction, or we can think of it going in the negative direction. Either one is fine because it only depends on where that terminal side lies. So what do we have? We have sine of theta is equal to -1/2. Okay, so sine of theta is equal to -1/2, and we have sine squared theta plus cosine squared theta is equal to 1. Then it seems like we should just be able to plug this in. So sine squared theta, so sine of theta is -1/2 squared plus cosine squared theta is equal to 1. Square that out, negative squared is positive, so 1/4 plus cosine squared theta is equal to 1. Subtract 1/4, we get cosine squared theta is 3/4. Take the square root of both sides. Cosine theta is equal to plus or minus the square root of 3/2. And now here we have to do a little bit more thinking. We're pretty close. We have it down to one of two possible values, plus square root of 3/2 or minus square root of 3/2. And to figure out which one it is, that's where we need that extra piece of information. The angle is in the fourth quadrant. Because in the fourth quadrant, we know that the x value is positive. And since the x value is positive, cosine is positive. And so we should be using here, cosine of theta is the positive square root of 3. I shouldn't say the positive square root of 3, plus square root of 3/2. And so we need to use the two pieces of information. First piece of information is the value of the sine function, which lets us plug in and get us close. And then the second piece of information is by knowing which quadrant the angle is located in, we can determine whether we want the plus sign or the minus sign.